Hey, 11th graders. So we are continuing on with Voronoi diagrams. Today, we are going to finish up Voronoi diagrams as far as we can get before time. So we've learned last lesson about how to interpret Voronoi diagrams, vocab behind Voronoi diagrams, the different ways that we evaluate when we have a Voronoi diagram, and then we talked about how to make a Voronoi diagram. On the IB exam, you will never be asked to make a Voronoi diagram of this extent, right? Like that's a very extensive Voronoi diagram. If you wanted to do an IA as a Voronoi diagram, you might be expected to do a Voronoi diagram of this level. But on the actual test, your level will be at like 3, 4, maybe 5 points. But on the IB questions, I don't tend to see more than 4. So just keep that in mind that you'll be expected to make not a lot. So this is at the level at what you're expected to make. Let's talk for a minute about like why or how we might apply Voronoi diagrams. Now, basically, anything that you can think of in regards to what I would want to represent spatial proximity to, you would use a Voronoi diagram, or you could use a Voronoi diagram to talk about it. So this is a Voronoi diagram, a 3D Voronoi diagram. So on the app, you could like turn it around and see the world, which is cool. And it's the world airports as a Voronoi diagram. So you can see like there's a site right here and there's a site right here and sites in the center here. And those are all airports, and then each cell around it is saying, okay, if you're anywhere within this cell, this airport is the closest airport to you, which is kind of cool that there are no lines drawn on this map that actually represent landmass. But you can see from the Voronoi diagram the landmass of, you can tell which continents these are supposed to be based off of the land masses that you can kind of shape out here. Whereas like the large empty spaces are going to be your oceans. You can see this is North America and South America. Europe's kind of starting to form up over here. So interesting in that regards. This is a map of a old London town during the cholera outbreak in like the mid 1800s. They had a massive cholera outbreak and they couldn't figure out how, like what this epidemic was doing and why people were getting sick and dying. And so the first epidemiologist, so now that we are in the age of COVID, we know what it means to be an epidemiologist. It's somebody who studies epidemics. And so Fauci is an epidemiologist. And the first one was called Jon Snow. No, not Game of Thrones Jon Snow, but the original Jon Snow, epidemiologist. And what he did is he created the first Voronoi diagram. Well, not the first one, but he created a Voronoi diagram of all of the water faucets in the city. So everybody would get water from a communal water faucet that would pump water. And so he did a Voronoi diagram of that and then took these specific dots, which represented infected cases, and noticed that all of the infected dots, or most of the infected dots, were within the cell of one water faucet. And so then he noticed, this water faucet is contaminated and that's how people are getting cholera. And so he was able to solve the pandemic or the epidemic by being able to use a Voronoi diagram, which is pretty freaking interesting. This is a screenshot from a Pixar video, which you can find on our resources page that I talked to you about, like an interesting art way of applying Voronoi diagrams. Pixar's programmers used Voronoi diagrams in order to create patterns of scales on dinosaurs for one of their movies. So if you think about anything that goes into a computer, including computer animation, it needs to be made via programming. And so they have to be able to program or create a mathematical way to represent something to the computer, because the computer really only speaks mathematically. And so they used Voronoi diagrams as a way to speak artistically to the computer to be able to create the texture of the scales. So there's all sorts of different representations. There's a couple ideas that I've had of like IAs that I would write if I were to write an IA, and I think I would write one on Voronoi diagrams because I think it's interesting. But if I wanted to represent the spatial awareness of people when they go on a tram, if they can represent equally spaced distances, if I tell people to like do that, right? So then you could like tell people to go into a rectangle and be like, okay, that's equally the size-ish of a tram car, be like, okay, go ahead and sit or stand wherever you want to like represent how you would space yourself out on a tram. And then we could do like a Voronoi diagram of all of their spaces and compare the areas of all of the cells to see if the areas are equal. Because if they're equal, then you've like equally spaced yourself out, right? Also, I've thought about when I've gone on hikes to like see different canopies of trees above me and to see all the different varieties of like some trees take up a lot of space and some trees don't take up a lot of space. And I thought it would be interesting if you could have trees be a specific site and create a Voronoi diagram of those trees, and then be able to compare the area of the cell that encompasses the tree and compare that area to maybe the trunk size to be like, okay, if they cover more space, right, if they have more space available to them as a tree, are they then growing larger because of the space that their leaves have to make? So you can make this comparison between how much space the tree has around it to like how much it can grow. So there's all sorts of ways that you can use a Voronoi diagram in order to represent real life. There's all sorts of applications. And if you just kind of think about a Voronoi diagram anytime you try and think about spatial awareness, there could be some really interesting things that pop up in your day-to-day life that you'd be like, oh, I could use a Voronoi diagram to represent this. Interesting. So keep those in mind as potential IA ideas. We've talked a little bit already about the nearest neighbor interpolation, but here we have a Voronoi diagram, and it gives us information about water measurements at those specific places. I've lost my pencil. Hold on. So you can see here that we've got all of these individual spaces. They collect rain when in those spots, and we're saying, okay, if you are living closest to this water collection, then this level of measurement of volume in the gauge is how much you have, right? So we're at point P here, and it says use the map to estimate the rainfall at this coordinate. But we don't have a Voronoi diagram yet. We don't know which of these coordinates are closest to P. So we need to create one. Now, we don't have the exact coordinates here. These points are kind of in between. So what we're going to do instead of actually calculating it like we did in our previous example, we're also going to talk about the importance of being able to quickly sketch a Voronoi diagram. Being able to quickly sketch a Voronoi diagram will be able to help you to guarantee that you are drawing the Voronoi diagram correctly when you do it mathematically. It's also a great way when you actually do it on the test to be able to kind of clue in to where it's supposed to be drawn. So with all of our Voronoi diagrams, we always start with a triangle, right? Because we know that all of the perpendicular bisectors of a triangle are going to meet at one place. So I start with a triangle and then I build off with that triangle as I go. You could start on any triangle. I think it might be easier to start in the middle and then build off from there as opposed to starting from the side, just because in the middle, it'll just be easier. So I'm going to start between here and here. I'm going to just think of the idea of a perpendicular bisector. So a perpendicular bisector has to go through the midpoint and it runs perpendicularly. So if I'm trying to think about the midpoint between here and here, that's going to be there-ish, right? About halfway. You could use a ruler to try and like actually find what would be halfway in between, but I think it's about there. And then if this is the way that segment runs, running perpendicularly to that will be like something like this. And I can even get out my ruler, which is why I got it, to try and do something perpendicular-esque. I'm going to erase this part of the segment just so that way I'm only focusing on the perpendicular bisector. Since I'm focusing on this triangle, I'm then going to rotate my page. And again, try between these 2 points. There you go. So between these 2 points, midpoint is like there-ish. And if this is the way the original segment goes, then perpendicular would be something like that. I'll get out my ruler. I can even start erasing parts of the domain that I know I won't care about. And remember that we restrict our domain by looking at, okay, this is the fence that splits up this and this. And the moment it hits that point of concurrency, I don't care about it afterwards. So once I get what I think will be my point of concurrency, I can go ahead and start erasing parts of the line that I'm like, I don't think the perpendicular bisector is going to go further out from there. And again, this perpendicular bisector splits these 2 points. So once it hits this point of concurrency, it doesn't matter anymore. So I erase that top part. And then, since I'm doing this triangle, going to focus on these 2 points and do my last two. I'll even do it upside down. Midpoint is going to be something like that. And then running perpendicularly to that, I'm going to try and not be swayed by knowing that it's technically supposed to go through that point as well, and try and be as perpendicular as I can. And yeah. Okay. So I've started my Voronoi diagram by just focusing on this triangle right here and building those perpendicular bisectors. Now I get to build off. I get to focus on a different triangle. So since I did this triangle first, maybe I'll focus on this triangle next, including 2 points from my original triangle and 1 more point. So I've got this perpendicular bisector. Now I need to do this perpendicular bisector. Starting with the midpoint, thinking 90 degrees-ish. Thinking, okay, so I won't care about it after here, and I won't care about this guy after that point, because this is the perpendicular bisector between these two, and after it hits that point, it's no longer splitting that space evenly. Okay, I did this, now I need to do these perpendicular bisectors. So between these 2 points, it seems like this is our perpendicular bisector, pretty much at the point of concurrency. I won't be going into this cell. I'll only be going away from this cell. Running, if this is our segment, 90 degrees-ish, just try and eyeball it. It's going to be something like that. Okay. So see from there, just adding in one more point, focusing on a different triangle, I was able to kind of expand my Voronoi diagram. I'll erase this guy that I was trying to be perpendicular to. And then I focused on this triangle first, this triangle next. I'll focus on this triangle to kind of expand out all the way this way. I've got the perpendicular bisector between these two, but I need the perpendicular bisector between these two and these two. I'll focus on the last two.